You ever wonder what really makes one computer feel like it's lightning fast while another one just chugs along? It's not always about what you think. Today, we're going to pull back the curtain and show you the secret ingredient to that snappy, responsive performance you crave. So, let's get into it.
So, what is it? What's the big secret? Is it just the processor? The brand name? Maybe the price tag? I mean, we've all been there, right? You click on something, and then you just wait and wait. Well, it turns out the answer is this surprisingly clever trick that your computer is pulling off thousands of times every single second.
And that trick, the real secret to all that speed, is all about being efficient, and more importantly, avoiding one huge roadblock.
Okay, so here's the fundamental problem. Your computer's processor, its brain, is incredibly, mind-bogglingly fast, but it's constantly getting held back. It's forced to just sit there and wait for data from the computer's main memory, which by comparison is much, much slower. That waiting game, that is the bottleneck, and it's the absolute #1 killer of performance.
To really get how computers solve this problem, let's use a really simple analogy. Just imagine you're a researcher, and you're trying to write a paper. You've got two ways you can work, from a gigantic library or from a small personal desk.
Now, the library, it's got every book you could possibly ever need, but finding just one of them takes time, right? You got to get up, walk through all the aisles, search the shelves. It's a whole process. Your desk, on the other hand, is tiny, but the few books you have on it, they're right there, literally within arm's reach. Access is instant. It's pretty obvious that working from your desk is just fundamentally faster.
Okay, so here's how we connect the dots back to your computer. You, the researcher doing all the hard work, you're the CPU, the processor. That giant, slow-to-access library, that's your computer's main memory. And that small, super-fast desk, that is cache memory. That right there is the secret ingredient.
So now that we've got the basic idea, let's really get into the nitty-gritty and see how this all works under the hood.
So technically speaking, cache is a special kind of memory. It is much smaller, it is way, way faster, and yeah, it's also a lot more expensive than your main memory. Its entire purpose in life is to hold on to copies of the data that the processor is probably going to need again really, really soon.
Where it's located is absolutely critical. You can almost think of it like a VIP lounge for data, sitting right there between the super-fast CPU and the slower main memory. It acts as this high-speed buffer, making sure the CPU doesn't have to make that long, slow trip over to main memory unless it absolutely has to.
And this is the process that makes it all click. When the CPU needs some piece of information, it never goes straight to the library. No, it always checks the desk, the cache, first. If the data is there, bam, access is instant. That's a huge win. If it's not, okay, it has to make that slow trip to main memory. But, and this is the really clever part, it brings a copy of that data back and puts it in the cache for next time, basically making a smart bet that it's going to need that exact same data again soon.
This whole system, it really lives or dies based on how well it predicts what the CPU is going to need. And you know what? There's a special term for when that prediction pays off big time.
It's called a cache hit. A cache hit is that perfect, beautiful moment when the CPU checks the cache and yep, the exact piece of data it was looking for is sitting right there, waiting for it. It is the absolute best case scenario. It's the goal of the entire system. And listen, this isn't just some casual industry slang. This is the whole ballgame. The entire capability of a cache is measured by how often it scores one of these hits. It's why the hit rate is the single most important metric for this technology.
And at the end of the day, it's really that simple. The more cache hits you get, the less time the processor spends just sitting around, waiting. Every single one of those hits saves a tiny fraction of a second. Now, that might not sound like much, but when these are happening millions of times over, all those tiny fractions add up to that huge, noticeable difference between a computer that flies and one that just crawls.
So, let's put it all together. Cache memory is basically like a brilliant personal assistant for your CPU. It anticipates what's going to be needed next, it keeps that information right there at the ready, and it saves the CPU from having to make that long, slow journey to main memory. It's a simple idea, really, but it's an incredibly powerful system designed to turn waiting time into working time. And that is the real secret behind a fast computer.
And that leaves us with one final thought. You know, this whole principle of keeping the stuff you use most often close by for fast access, it's everywhere. So think about it. What in your own life works like a cache? Isn't your kitchen spice rack? The shortcuts on your phone's home screen? Give it some thought. Thanks for joining me.